Alright, this is a review video for Spanish River Honors Chemistry to get you guys used to doing ionic bonding. I'm going to simplify it, make your ionic bonding experience a little bit better. So let's simplify this and go over it. Well, you've already been learning about basically ionic compounds, or we're making ionic compounds. Remember this, basically, an ionic compound is always a metal and a non-metal put together. So one of the things you have to be able to do on the quiz is determine whether or not something is ionic. Well, it's kind of like that movie Romeo or Nomeo and Juliet, that little kids movie. They were in one yard and the other one was in the other yard, and they were separated by a fence. Remember the fence on the periodic table that separates metals from nonmetals? So one way you tell an ionic compound is you have to have a metal, so like sodium and chloride. That makes an ionic compound because you have a metal which forms a cation, which is positive. It loses electrons to get to 8. And chlorine, which gains electrons to get to 8, an octet. So it's like Romeo and Juliet. So if you remember that, you can always spot an ionic compound, because when you take the test, you'll have a periodic table right in front of you. So an ionic compound is always a metal, a cation, and an anion. Cations always lose electrons, and that makes them positive. Anions gain electrons, and that's going to make them negative. So when they ask you on the quiz, which one gains electrons or which one loses electrons, you know by the structure of the periodic table. Metals lose electrons, they become positive, and it takes one of those, Romeo, with a Juliet on the other side to make an ionic compound. So like calcium oxide would be a compound, an ionic compound, because the two of them are together. What would not be an ionic compound would be like nitrogen and fluorine put together. They're on the same side. You need one from each side of the fence. All right, next key thing is when you look at the periodic table, you need to know the number of valence electrons and the charges. Well, how do we do that? Well, if it's in group 1, it automatically has a charge of +1, +2. This group is going to be +3. We're going to call this nothing. Then it goes -3, -2, -1, and this is 0. The number of valence electrons you can tell as well. I'll put that in a different color, put that in red. This is 1 valence, 2 valence, 3, 4, 5, 6, 7, and 8, except for helium. So you have to be able to look at the periodic table, especially if you're going to do ionic bonding, and determine what the... So by looking at the charge on the periodic table, you should be able to tell what a charge is. For example, like magnesium. Magnesium is going to have a charge of +2 where it is. Potassium is going to have a charge of +1. Sulfur is going to have a charge of -2. All right? So next thing. This is what you have to be able to do for the test. You'll be given 2 elements, and you have to make the ionic compound. You have to show the transfer electrons, all that stuff. So first and foremost, the electron dot structure is just the number of valence electrons in. So we're going to do number 1. We'll do aluminum and sulfur, this one right here. So when you go to do an electron dot structure, what does that mean? You go back over to the periodic table. You find the number of valence electrons. Aluminum has 3. Sulfur has 6. So what's it going to look like? Well, if you go to do that, you're just going to go aluminum. And then you're going to go 1, 2, 3, and then I'm going to do sulfur. Is going to be 1, 2, 3, 4, 5, 6. Now, the second thing you have to do is you have to show the bond distribution. But there's an easy way to figure out what the ratio is. I teach that you should do the ratio first. It just makes it easy. So I'm going to go back and look at the charge on aluminum. When I go back and look at the charge on aluminum, the charge is 3+. The charge on sulfur, 2-. So what I'm going to do before I start the bond distribution is I'm going to do this. I call it the crisscross method. I'm going to go, we'll do it on the next slide. I'm going to go Al 3+, and then sulfur 2-. What we do here is called the crisscross method, because to get the ratio that you need to draw them out, it's actually easier if you do it ahead of time. So I need my ratio, so how am I going to get it? Well, what happens when you make an ionic compound is the number here and the number here become subscripts on the other side. So what you do, it's called the crisscross method. All I'm going to do is, it's going to tell me I need, if I ignore the negative and the positive sign, but I'm going to take the 2, I need 2 aluminums, and then I crisscross the 3 over here, I need 3 sulfurs. So when I go to do the bond distribution, I already know it's going to be Al2S3 from crisscrossing the charges. So when I go to do the bond distribution, I know I have 2 aluminums and then 3 sulfurs. So I'm going to go Al1, Al2, Then another color. I'm going to take sulfur. Sulfur is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Sulfur here, 1, 2, 3, 4, 5, 6. Then all I have to do the distribution is this. This has 6. It needs 2 more. 1, 2, done. Then I take 1, 2, done. 1, 2, done. Boom. That's it. That's how you do the bond distribution. So crisscrossing is what you want to do first. That's also going to be your formula. 2 aluminums and 3 sulfurs. You're good to go. Next step, electron configuration of the atoms. Well, this one you should already know at this point. It's going to be 1s2, 2s2, 2p6, 3s1, 3s2, 3p1. That's the electron configuration for aluminum. Sulfur is going to be 1s2, 2s2, 2p6, 3s2, 3p4. Those are the normal electron configurations. This is where the charge comes in handy again, because all you do to the electron configuration is the opposite of whatever the ion charge is. Meaning if aluminum is 3 plus, it means that on the electron configuration, I take off 3 electrons from the end, highest energy level. If sulfur is 2 minus, the opposite of 2 minus is going to be 2 plus. So I come back over here. This is the electron configuration of the atoms. If I go to change this to ions, all I do is this. So on the separate below, I would do Al3 plus, and then S2 minus. If this is 3 plus, the opposite of 3 plus is 3 minus. I have to remove the 3 electrons from the outermost. Well, there's 1 here, gone. This is 3s2, 2 there, gone. That gives me a valence electron shell of 8 electrons. So I have 8 valence electrons. So that reaches a noble gas. The next one, if I look here, S2 minus. What does that mean when I'm 2 minus? It means that I add 2 electrons to the end. So I'm going to come over here to the end, and I'm going to add 2. This is going to make this 3p6. So that's the electron configurations for the ions. Done there. Formula of the ions. The formula is just what I already showed you. You write the symbol and the charge. So aluminum is 3 plus, sulfur is S2 minus. Name the ions. When you go to name the ions, positive ion basically is just the same. So if I have Al3 plus, I'm going to just call it the aluminum ion. That's it. It's supposed to say aluminum. S2 minus. Any negative ion, the ending gets changed for right now. It gets changed to IDE. So we're going to take sulfur, which is normally like this, and we're going to change the ending. We're going to add IDE as an ion. So then it becomes that they ask me, the second thing is to name the compound. It's just going to be aluminum sulfide would be your answer. Finally, the formula of the compound we already figured out because we already crisscrossed it, Al2S3. Use the crisscross method. It's the best way to do these. So I'm going to do one more real quick. I'll do one more from scratch. I'm going to pick calcium and oxygen. Actually, I'm going to pick calcium and oxygen. If you go to do it, calcium is Ca2 plus, oxygen is 2 minus. Notice how the same number, that means lowest whole number ratio would be 1 of each. It's going to be 1-to-1 ratio, which means you would just take 1 calcium and 1 oxygen and you would be done. So I'm going to skip that one. I'm going to do one that's a little bit more difficult. We'll do strontium and chlorine. So I go back to my magic periodic table. Strontium is right here, charge is 2 plus. Chlorine is right here, charge is -1. So I'm going to go back over here, and I'm going to do it on the next slide. So I'm going to clear this. Electron dot structure, strontium is going to be 1 dot, 2 dots. Chlorine, is it chlorine we're pairing with? Yeah, chlorine. Chlorine is going to be Cl, 1, 2, 3, 4, 5, 6, 7. Now, my first step is I'm going to crisscross. So I'm going to take Sr2 plus and Cl -1 basically is what it is. Ignoring the plus and the minus, I'm going to crisscross to get my ratio. Means I have 1 strontium, 2 chlorine, so my formula is SrCl2. So then when I go to draw it, I automatically know I go Sr dot dot, Sr dot dot, then I go Cl1, whoops, that's actually, my bad, that's 1 Sr, 2 Cls. So I'm going to erase this, and I'm going to go Cl, I get too excited. See, Bonnie gets me excited. Boom, and then I make it Cl, boom, 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 boom. Now, I transfer my electrons. How am I going to do that? Well, one goes here, boom, gets an octet. One goes there, boom, gets an octet. So there is my bond distribution done the easy way. Crisscross before you do it, and you'll be good to go. Now, electron configurations, I figure you guys can do electron configurations. Since strontium is 2+, that means that I'm going to remove the 2 electrons from the outer level. Chlorine is 1-. I'm going to add an electron. When I go to name these, this is going to be the strontium ion, and then this is chlorine normally. Since it's a negative ion or an anion, I'm going to change to chloride ion. So the name of this is strontium chloride. It's going to be strontium chloride, and the formula is SrCl2, and that's all you need to know about ionic bonding. Hopefully this helps, and have a good rest of your day. All right? Thanks.